Okay, so this is a quick introduction on my FYP project. This is the gantry I'm using to do the battery cell sorting. So basically I'm using a 3-axis Festo gantry system. The cells are loaded in this area to be tested. This is my pass tray, and this is the small rig for testing the electrical. Basically the battery is positioned over here by the gantry system. Then the pogo pin over here extend and take measurements of the voltage of the battery. I'm also taking a reading of serial number of the battery cell. So each voltage is recorded to a battery. For the measurements, electrical measurements, this is the multimeter, and this is connected to the PLC through RS232, so this is the feedback to the PLC. In terms of panel, I guess as mentioned previously, I'm using Festo X, Y and Z axis Cartesian, and this is the power supply that fits the 48 volt for the gantry system, and this is the power for the PoE for the Cognex 1402 camera vision system. Then basically just protection for the power supply, the two power supply and the PLC that is over here. In terms of PLC, I just have a Ethernet switch. This is the CM1241, which controls the serial number, the RS232 connection to the multimeter. This is the PLC. It's a 1215 model, which allow the control of 4 PTO axis. So this is what I'm using for controlling the stepper motor. One of the modules uses 5 volt control for the Festo drive, and this is connected over here on this side. This is the X10 and this is X1 for basically for the 5 volt control. I'm using an add-on module that is over here for controlling the step and direction of the X and Y axis motor, and that gives me around 200 kilohertz speed for controlling the motor. Couple of IO extra, so I'm only controlling the electro valve. Festo electro valve for the pneumatic is actually over here. So this is the vacuum, which is the suction cup that you have here. This is my PEb inline vortex vacuum system, so just create basically when it's activated a vacuum. The second electro valve and third one is for the cylinder. So we can see here I can activate this one manually here, and that will make contact with the pogo on the top side of the battery, and on the bottom side, if I can catch it, not really now, there's another cylinder basically on the bottom side, and this one is for the other side of the polarity of the battery. So these are the X and Y axis, and the Z axis is over here. What else to say? Just the main controls, so start, stop, e-stop and reset for the drive, and well, I suppose we can just go back to the HMI and just have a quick scan through that. So jog mode is what I'm using for moving the axis, X, Y and Z, and this is my coordinate system. This is just for the equivalent of the push button that we have in front of the panel. Pick, teach, this is for teaching the position of the pick position of each cell from the load tray. So every individual cell is selected and the coordinate is recorded, and that's basically saved into the database. I probably will go into the next video for the the actual code. So at the moment I'm just presenting the screen for HMI here as well. So same again, all the positions are recorded on X, Y and Z on the data block, and this menu allowed for saving the coordinate. Then we have a small table here for vision measurements, which is basically the serial number recorded from the inside camera, and this is the TTI measurement from the RS232 module. Then what else do we have? That's about it. Maintenance screen hasn't been done yet, so maybe I will have it updated by tomorrow. And yeah, that's it. So we have the auto mode active here, and this is the IO synchronize mode and teach mode, which by switching the mode I can home the axis, each individual axis, and then switch back to synchronize mode, which just kind of move absolute of the axis of the motor. Then I had it on pause at the minute, so I can just take it from there and we can have a quick look at what's going on the actual rig. So this cell is picked by the vacuum system and it's brought to the Pogo electrical test station, and in this position then there is an electrical measurement performed here, and the camera serial number is also scanned by the vision system, and then it moves it to the next available location for past batteries, and that goes on to the next selected battery again. So picking up the cell, loading, contact. You can see the measurements here of the multimeter briefly, and this is all logged back to the PLC. So same again, there is a little delay because of the fact that the cells are a bit wobbling. So there was a plan to design a small 3D printed fixture to hold the battery from shaking and then maybe increase the cycle time, but I didn't manage to get to that. Then we have the measurements here, so the serial number is recorded, and this is the the voltage was over here, so we can manually enter the limit. So what voltage will we reject, for example, the battery cell. So if I change back to 0, then we can look at the next measurement, and it should technically no limit. I don't know. I think it's probably, I'll put it back to 2.5, and what I'll do is, so to simulate the failure, we can simply block the continuity here on the cell, so that should produce maybe a fail, because the battery will not record. So if I stop the contact now, we have 0 volt measurements, and then I take that quickly. So then this cell should be moved to the reject tray. So same again, a small delay to allow for the battery to settle, and this is a reject, and back again to the next position over, and then like that it just basically go through the whole tray. If there is any more than 10 battery rejected, then it will prompt on the HMI
to empty the tray and continue, so unload and continue. That's it. I'll be speaking in detail about the code on the other video. Thank you.